If the worker ant at B exerts a force of F1 of 30 pounds on the rope, determine the magnitude of the force F2 at C to prevent the pole from tipping, that is, so that the resultant moment about A of both forces is 0. So in this particular case, we're going to assume that at A, it's not embedded in the ground, but simply this pole is resting on the ground. Okay, so in this particular case, we have this ant is pulling in this direction and this ant is pulling in this direction. So we want to make sure that everything is perfectly balanced so that this pole is not going to tip about point A. Alright, so we're going to take the moments about point A. And in this case, it has to be 0 according to the instructions. The resultant moment is 0. Okay, and of course that's going to be the summation of the force times perpendicular distances. Alright, well, before we can do the force times perpendicular distance, we need to go ahead and break up our forces into their various components. So F1 has a component here horizontally, and of course down. And over here, same thing, horizontal component and a vertical component. Alright, well this horizontal component right here for F2, we're just going to use the relationship of the 3, 4, 5 triangle. So the horizontal component is going to be 4/5 of the hypotenuse, F2. So we have 4/5 of F2. In F1, we're going to use the angle relationship. Okay, so the horizontal component is going to be F1 cosine of 45. So F1 cosine 45. Now I'm not going to waste any time doing the vertical components for this particular problem, because you can see that when I take moments about point A here, that the vertical components are passing right through point A. In other words, there's no perpendicular distance to the vertical components. Alright, so all we need to worry about in this particular problem are the horizontal components. Alright, we do need to worry about our sign conventions here. Alright, so we're just going to use the classic convention that counterclockwise is positive and clockwise is negative. So let's start with F1, and you can see that it is going to rotate clockwise about point A. So we're going to label that as positive. So we have F1 cosine 45 times its perpendicular distance, which happens to be 12 plus 6, 18. Okay, then we have our F2 force, which is giving us negative rotation. You can see that it's going to rotate like that. Okay, so we have the horizontal component 4/5 of F2 times its perpendicular distance, which is 12. Well, we know the value of F1 is 30, so we can make that substitution here. And now we can go ahead and solve for the value of F2. And we get 39.8 pounds.